Good morning, everybody. Welcome to the session. Today we are talking about matter around us, science for class 7. Science for class 7, matter around us. We will study out elements, compounds, atoms, etc. Everything we see around that occupies space and has a mass is called matter. So what is matter? Matter is something that has mass. Matter is something that occupies space. Matter has a space, occupies space and has a mass. So all the things that we see around us, most of them can be classified as matter. Now there are certain things which cannot be classified as matter. For example, heat, light, sound, etc. They do occupy some space, but they do not have a mass, right? So heat, light, and sound is not part of matter. But anything else which has a mass and which occupies a space can be called as a matter. So what exactly is matter? Matter is something that is composed of tiny particles which cannot be seen by naked eye. That means what? A combination of lot many small particles which form a substance is called matter. So if these particles are very closely fused, we call it as solid. If they are little bit loosely held, we call it as liquid. If these particles are far away but still in a cohesion, in a fusion, they stay together, we call it as a gas, right? So matter is something that has mass, that occupies space, that is composed of tiny particles. The smallest unit that exhibits properties of any matter will normally be called an atom. So is atom the smallest particle of any matter? Not necessarily. The matter that we see around can be divided into three groups: elements, compounds, and mixtures. Mixture is air. Air contains oxygen, hydrogen, carbon dioxide. All together it's a mixture. So it is called a atmosphere is called a mixture of gases. So that is a mixture. What is a compound? Sodium chloride is a compound. What is sodium chloride? NaCl. That is the way we write it in science. In normal day-to-day life, we call it as sodium chloride. That is a common salt that we use in our food. That's a compound. Why? It contains or consists of sodium and chlorine. So what are these components that form the compound? They are called the elements. A substance, a matter that can independently exist is called an element, like sodium, like chlorine. Two or more substances which combine together in a definite proportion is called a compound. That is sodium chloride. 1 unit of sodium, 1 unit of chlorine is called sodium compound. It's a compound. Then two or more substances which combine together but not in definite proportion is called mixture. Why we call it as a mixture? Though we say 70% of atmosphere is maybe nitrogen, or 1% is carbon dioxide, or 20% is oxygen, like that we have different percentages. These percentages are not exactly hard and fast ruled. Sometimes there may be a situation where the atmosphere has little bit more carbon dioxide. There may be situations where the atmosphere has a little bit more oxygen. So nearer to tree during daytime you feel like more fresh because the oxygen is more because of the photosynthesis. During nights near the tree you feel little bit suffocated because it is not that much oxygen but more carbon dioxide because plants also breathe out carbon dioxide. So the concentration of different components in a mixture can keep on changing. But in a compound the components, the constitutions does not change because two or more elements combining together in a definite form is a definite proportion, definite composition, definite formula, definite portions or fractions is called a compound. So smallest unit of an element that exhibits all properties of an element is called an atom. So if sodium is an element or hydrogen is an element or carbon is an element, the smallest unit of that, you keep on cutting it and slicing it and making it a powder, the smallest unit that cannot be any further divided, which exhibits all the properties of that element is called atom. Atom is the smallest indivisible unit of an element that exhibits all the properties of an element. Earlier people thought atom is the smallest thing and you cannot divide it any further. The indestructible or indivisible part of an element or a substance. That is what people thought. But now we know atom can also be further subdivided and learnt and understood in its constituent forms that we will see later. So if this is atom, which is the element or which is the substance that is most commonly found in the atmosphere? The most abundant type is hydrogen. When you talk about the whole universe is what? Universe is a big thing. Smaller than that is a galaxy. Smaller than that is our Milky Way or the sun and its solar system. Smaller than that is the earth. Smaller than that is the atmosphere on the top of the earth. So if you look at our biosphere, where the atmosphere, lithosphere and hydrosphere meet, On this biosphere, the most abundant type we find hydrogen is there. So when you go out into space towards Mars, towards Sun, whichever direction you go, into the Milky Way, into the universe, you find hydrogen is the most common or most abundant type of atom. On Earth itself, on lithosphere alone, if you see, then iron, oxygen, silicon, etc. are the abundant atoms. Actually, we should say abundant elements, right? But why we say atom? Because atom is the smallest unit, the indivisible unit, the smallest smallest possible particle of an element is an atom. So what is molecule? If this is an atom is the smallest possible particle of an element, molecule is the smallest possible particle of a compound. Molecule is the smallest possible particle of the compound. Molecule is two or more atoms chemically combined. A few atoms of different elements will be there on a molecule. Molecule also exhibit the properties of the matter. That is, they exhibit the properties of the compound. They may or may not reflect the properties of the constituent elements. For example, the quality of chlorine or the quality of sodium or the characteristics or the properties of sodium and chlorine are different. And that of sodium chloride is entirely different. Not same as this. A third type of characteristic or a property will be displayed by sodium chloride. But the molecule of sodium chloride will have all the properties of sodium chloride. The atom of sodium will have all the properties of sodium. Atom of chlorine will have all the properties of chlorine as an element. So molecules exhibit properties of the matter. They have individual existence. They may or may not have properties of the constituent elements. Now, molecule consists of a fixed number of different types of atom chemically combined. The bonding of the sodium and chlorine is chemical bonding. They have a fixed number, a definite proportion, a standard proportion of the constant combination. If the constant combination is not a fixed number, if it is not definite, if it is variable, then it will be called as a mixture. Okay, now this is how we represent the molecules. This is one type of atom, this is another type of atom, two different elements, and red is a third different element. So white is one type of element, gray is one type of element, red is one type of element. This is how we represent. What this is actually, this is benzoic acid. So all this will be carbon, these are oxygens, and then you have hydrogen also. So two red is two oxygens, and this white is a hydrogen. Right, this is how we write benzoic acid. Now this is how we write ammonia. Ammonia is what? NH3. That means what? One element called nitrogen and another element called hydrogen. What is the proportion? For every one nitrogen there will be 3 hydrogen. So 1:3. How do we write NH3? 3 should be on the subscript. NH3 is what we write. So when we write ammonia as a common name, NH3 as a chemical name, this is how we represent. This is called balls and sticks method. This is balls and sticks method. Every ball will be one element, every stick will be the connecting bond. So this is nitrogen, and these three are hydrogen, and there are 3 bonds. That is why there are 3 lines. Here there is one bond, this is one line, and then from there are 2 types of bonds. So like this and like this. So this is how we write. OH is called hydroxy, right? Now this is ammonia. Now this is sulfur. What is the specialty of sulfur? Sulfur can exist independently, but sulfur does not exist as one atom of sulfur. It exists as 1, 2, 3, 4, 5, 6, 7 like that. So 8. So 8 units of sulfur, 8 atoms of sulfur, together they exist. So it is called S8. So if 8 units are there, then it will form a molecule. Why? A molecule is the smallest particle of a compound. Compound is one or more element in definite proportion. Here it is one element sulfur in the proportion 8 times unit 8 atoms of sulfur. So 8 atoms of sulfur form a compound, sulfur compound, and sulfur atoms are denominated like this in the ball and stick method. Now this is sulfuric acid. What is sulfuric acid? Sulfur plus hydrogen plus oxygen is sulfuric acid. How do we write? How many units of sulfur are there? There are 4 units of oxygen. This red is oxygen. There is 1 unit of sulfur. This yellow is sulfur. And this white are hydrogen, which forms the OH. OH is hydroxy, HOOH. This is why we call sulfuric acid as H2SO4. 2 hydrogen, 1 oxygen and O4. H2SO4. That is how we write. And 4 is in subscript. 2 is in subscript, H2SO4. So when we write H2SO4 as a formula for a compound, H2 stands for 2 units of hydrogen, O4 stands for 4 units of Oxygen, we write subscript to represent how many units of that particular atom or element is there in that compound or molecule. Normally, when we write this symbol, this represents the number of atoms in one molecule, right? Of that molecule is the smallest particle of the compound, while atoms is smallest indivisible particle of the element. Molecule and element exhibit molecule and atom exhibits all the properties of the respective compound or respective element. Oxygen is an element, hydrogen is an element, ammonia is a compound, sulfur is an element as well as a compound, sulfuric acid is a compound where oxygen, hydrogen and sulfur are the component elements, right? Now, if this is a way, here you have 4 oxygen atoms, here you have 1 hydrogen atom. So, what do we mean? We say monoatomic. Monoatomic means one atom of the molecule will independently exist. Inert gases. What are inert gases? Argon, neon, etc. There are very small traces of inert gases in the atmosphere, not even 1%, less than that. Monoatomic means one atom independently exists all alone, singleton. Diatomic means what? Two atoms will form together to form a molecule. Two atoms together will form a molecule, both of the same element, hydrogen. Unfortunately, both the spellings are wrong. Okay, oxygen, hydrogen and all exist as two atoms. That is what? H2O2. That is how it will be there. So, for example, here we have to say argon, or neon. Here we will say H2 and 2 we cannot write like this. We have to write it as a subscript. What is subscript? Subscript is writing on the below right hand side. Superscript is writing on the above. This is O3 oxygen. O2 is oxygen. O3 is ozone. O3 is ozone. So ozone, sulfur dioxide, carbon dioxide and all exhibit as a triatomic. Three atoms together will form carbon dioxide is two oxygen and one carbon, CO2. That is how we write carbon dioxide. Polyatomic means what? Poly means many. Polyclinic, you know, polytechnic, right? Polyatomic. Polyatomic is the molecule of phosphate is a polyatomic. Molecule of phosphate is a polyatomic. Why? Multiple atoms will be there. Sulfur is polyatomic. Why? 8 atoms of sulfur together exist. So polyatomic, 8 atoms. Element is chemically simplest substance that cannot be broken down further. Element cannot be broken down further because it is chemically simplest substance. But element can be further broken down into atoms, which are the indivisible part of the element. Element is a chemically simplest substance means what? In ammonia, when you have NH3, you can divide this NH3 into N and H. That is the maximum possible. You cannot further divide that. But N consists of atoms, which are the indivisible part of N. Hydrogen H also consists of atoms, which are the indivisible parts of H, which cannot be further divided earlier. Now we can study the components. What are the components of an atom? We will see. There is a nucleus, electron, proton, neutron and all. Okay, now we have seen elements and compounds. Ammonia as a compound, sulfuric acid as a compound. We have seen hydrogen and oxygen as an element. What is mixture? Mixture is something where you have indefinite proportion of the component elements. That's a mixture. Okay, right. What are pure substances? Pure substances elements. That is why we say element is chemically simplest substance. It is pure. Hydrogen is the purest chemical form. Further division, hydrogen will not be hydrogen. So that is a chemically simplest substance which cannot be further broken down. So elements are pure substances. Compounds and mixtures are not pure substances. Why? Because they may have more than one element. Only one element is there, it is a pure substance. More than one element, it could be not impure, it could be compound or a mixture, right? Matter in its simplest form is element. Chemically cannot be divided further. There are 94 different natural elements, 24 different elements created by man. So totally we have around 120 or 118 elements today. These elements are represented in a periodic table. These elements are represented in a periodic table in a specific order, right? Now, these elements combine in proportion to form compounds. Proportion means what? Some fixed formula will be there. Definite formula, definite extent of the constituents. 1 is to 2, 1 is to 7 like that. Now, elements, some of them are metals, some of them are non-metals. What is special about metals? Metals are hard and shiny. They are used to make tools and utensils. They are malleable and ductile. They are semiconductors. Mostly they are sodium, except mostly they are metals. Except sodium, other elements are metals. And then they are solids, except mercury. Mercury is in liquid form. Otherwise, metals are in solid form. Sodium is not shiny. Mercury is not solid. Otherwise, they are good conductors. Carbon is not a good conductor, right? Now, on the metal characteristic, we can find that we can form them or draw them into various size and shapes. That means what? We can make a glass, we can make a plate, we can make a spoon, we can make a fork, we can make a wire, we can do a lot of things with these metals. You can beat it them after heating. That is hammering. We can roll them into plate or sheet as thin as possible. That is why we have gold jewelry. So they are malleable and ductile. Malleable and ductile means what? You can hammer them into thin sheet, you can roll them into any shape, and then you can draw them into any length of wire. Malleable and ductile metals. Non-metals are dull and soft. It is not hard and shiny, it is dull and soft, except diamond. Diamond is neither dull, it is bright and shining, it is not soft, it is hard. And then non-metals are mostly fluid, except carbon, iodine, sulfur, and carbon is a solid, iodine is a solid. Otherwise, non-metals are usually fluids, right? And then they are poor conductor of heat and electricity. Non-metals are usually poor conductor of electricity. This is about the elements. Elements, there are 94 plus 24 natural and created. They combine to form compounds. They can be metals or non-metals. What is a metal? Iron and silver. What is a metal? Bromine or iodine or carbon, right? This is about the pure substances. Why it is called pure substances? Because elements are the chemically simplest substances that cannot be further broken down, right? And what is non-pure substance? That is the compound and mixture. Okay. So then, other than metals and non-metals, we have metalloid. Metalloid is have the properties of both metals and non-metals, or some property of metal and some property of non-metal will be displayed by that substance. Example: silicon, arsenic, antimony, and boron. Silicon we get it from the soil. From the iron also we get from soil. Gold also we get from soil. But iron and gold have a metallic property. Silicon has some metallic and some non-metallic property. What is special about silicon? Silicon is used in semiconductors in today's electronics. What is special about arsenic? Arsenic is a poisonous substance. Boron is one of the inert gases, right? Now, among the non-pure substances, which is pure substances element, other than element, what do we have? We have compounds and mixtures. What is a compound? Pure substance that is formed when atoms of two or more elements combine chemically in definite and fixed proportion. Elements are chemically simplest substances that cannot be broken down. Elements are called pure substances because it is a matter in simplest form, right? But what is compound? Compound is pure substances that is formed when atoms of two or more elements combine in fixed or definite proportion. Two or more elements that combine in fixed or definite proportion. Why we have to say like this? Because from non-metals we know they are not lustrous, they are soft, they are not bendable, they are not ductile, they are not conductors, and they do not make sound when they are struck. Metals, they make sound, a clinging sound will be there. That is why school bells are made of metal. And then they are lustrous, shiny, hard, bendable. It can be bent, can be drawn into wire. That is malleable and ductile. Good conductor of electricity and heat. This is a metal and non-metal, right? So metal and non-metal, and then we have a third thing called metalloid, which are characteristics of both. So these are the elements which are normally considered pure substance because in the simplest form. But compounds are elements only. They are pure in the sense that pure substances are combining together, but two or more elements combine to chemically form a bond of fixed proportion of constituent elements. Definite or fixed proportion of the constituent elements, they come together to form a chemical bond, and that is called a compound. The smallest indivisible part of the compound is a molecule. For example, oxygen supports fire, right? Water is used as a fire extinguisher. Why we are talking about water? Because water is nothing but H2O. How do we write H2O? O should be subscript. Why O is subscript? Because two atoms of hydrogen and one atom of oxygen together form water. This is a compound. Hydrogen is an element, oxygen is an element. Hydrogen is combustible. Oxygen supports fire. H2O is forms water. Water is not combustible, but it can be used to put out fire. Totally opposite behavior. Sodium and chlorine are poisonous, but together they are not good and unsafe for consumption. But sodium chloride NaCl as a salt is there is no problem. NaCl is a salt. So what is Na sodium? What is Cl chlorine? So some elements are represented by the first letter of their English name hydrogen, oxygen. Some elements by the first two letters of their English name chlorine. Some elements their first letter of the not English name but a Latin Greek name sodium. It is coming from not SO but Na. So this is how we have the names. These names are also called as symbols. Names of the elements or symbols. The properties of the compound are different from the constant elements. Water has a different property, sodium chloride has a different property. This compound cannot be broken down in constituents by physical method. Water you cannot convert into hydrogen and oxygen by physical method. NaCl cannot become Na and Cl by physical method. Only by chemical method you can do. They are combined by chemical bond together in fixed and definite proportion. The combination is together in definite proportion of one or more elements. That is why they call it as a compound. Molecules are the fundamental particles of compound. Atoms are the fundamental particles of element. Atoms are chemically simplest substance. Compounds are substances formed by two or more atoms of different elements, right? Now what is a symbol? Symbol of hydrogen is H, sulfur is S, aluminium is Al, magnesium is Mg. So first letter of the English alphabet or first two letters. If a first two cannot be formed, first and any other letter Mg. Copper is cuprum, Latin name Cu. Likewise we saw another here Na from sodium, right? Potassium is kalium is the other name. So K. Plumbum first two letter cannot be taken. So first and Pb. So this is how the symbols are formed. These are the chemical names of the elements. Now number of atoms of this element plus number of atoms of this element together when they form a compound fixed proportion we get a compound. When there is a compound molecule the fundamental particle of the compound is mentioned by a formula H2O or NaCl. So it means what? When it is an element we call it as a symbol. When it is a compound we call it as a formula. For elements it is a symbol, for compound it is a formula. For compound, molecule is a fundamental particle, smallest indivisible particle. For element, atom is the smallest indivisible particle. Elements are the components of a compound, but they are chemically bound together. So the elements cannot be divided from or split from a compound by physical means. The component elements of a compound can be split only by chemical means. Okay. Now what is a chemical formula? H2O is a formula. Likewise, NaCl is a formula, H2SO4 is a formula, all this formula, NaCl is a formula, CH4 is a formula, all these glucose, what is glucose? Sucrose, sucrose is C6H12O6 and this O can become O7, O8 and you have different forms of glucose. That means what? Different forms of starch. When a plant produces food or human beings digest food, the food is converted into CHO compounds, right? C and H and O are there. Now water H2O, hydrogen and oxygen combine in the ratio of 2:1, 2 hydrogen, 1 oxygen. This is a chemical formula. This is a representation of a molecule. Each molecule of water has 2 hydrogen and 1 oxygen. Each molecule of water, it's a chemical bonding. They cannot be split by physical means, but by chemical means they can be split into oxygen and hydrogen. It is called electrolysis. When you do electrolysis, it should split. So from water we can get oxygen, from water we can get hydrogen. Same way, by a chemical method, you can mix oxygen and hydrogen to create water also. So this H2O is a symbolic representation of a molecule. While H is a symbolic representation of hydrogen, O is a symbolic representation of oxygen, H2O is a symbolic representation of water molecule. These are atoms of hydrogen and oxygen. NH3 is ammonia, NaCl is sodium chloride, CH4 is methane. These are the formula or the chemical representation of the molecule of the particular compound. What is atomicity? Atomicity is the number of molecules of hydrogen and nitrogen or oxygen mixed together, right? So when they mix together, some of them exist on their own as monoatomic. Some of them do not exist. So atomicity is the way in which they form a unit. The number of atoms present in the molecule of an element is a compound. The number of atoms present in one molecule of an element in a compound is atomicity. So in H2O, there are two hydrogens. So 2 is atomicity of hydrogen. The number of atoms present in one molecule of an element or a compound is atomicity. Number of atoms present in one molecule of an element or compound is atomicity. Why molecule of an element? Because hydrogen and oxygen we know exist as two atoms together, H2O2. Ozone is O3. It is only one element, but three atoms are together. That is why we call it as atomicity is 2 and 3. But what is a compound? H2O. H2O is a compound. H2 is an element. Some atoms exist in 2 or 3 units. We have seen monatomic, etc. Right? We have seen some are monatomic, some are diatomic, some are triatomic, right? So that is why we have this atomicity, total number of atoms present in one molecule of an element or compound. Phosphorus P4 molecule contains 4 atoms. Sulfur is S8. How we have to write 8? We have to write 8 as a subscript, right? Sulfuric acid H2SO4, 4 oxygens and 2 hydrogens. So total how much? 2 plus 1 plus 4 is 7 atoms are there total. So atomicity of sulfuric acid is 7, right? So this is how we arrive at or understand the atomicity, right? There are elements everywhere. Why? There is matter everywhere, and most of the matter has mass, and so we call them as elements or compounds or mixtures, right? 99% of the human body consists of 6 chemicals. What are the 6 chemical elements? Oxygen an element, carbon an element, hydrogen an element, nitrogen element, calcium an element, phosphorus an element, right? These are non-metallic. For example, carbon, calcium, phosphorus and all are non-metallic. Hydrogen, nitrogen, oxygen and all are gaseous elements, right? And then we have 5 elements which make up the rest of the 1%. 99% is oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus. That is why CH and O together make this glucose. CH and O together make this glucose. This glucose is starch. This starch is what becomes energy and fat and other things in our body. So 99% is these things. These are, we say, no, vitamins and minerals are necessary for our body. This calcium, phosphorus and all the minerals. Now, what are the other 5 elements which constitute the rest 1%? Potassium, sulfur, sodium, chlorine, magnesium. So potassium, calcium, phosphorus, sodium, magnesium, we need in small quantities, and oxygen, carbon, nitrogen, all this together make the components of a human body. So likewise, if you look at air, 99% is nitrogen and oxygen. 99% is nitrogen and oxygen. And then rest is carbon dioxide. Carbon dioxide is what? CO2. Carbon dioxide is CO2. And O we should write it as a subscript, carbon, oxygen. Right? And then is it so? Nothing else. So 99%, this is less than 1%. And what will make it 100%? Neon, helium, methane, argon, boron, all these are inert gases. Why inert? Because very small traces of very little amount of those gases, right? So these are the elements and compounds, or these are the components of matter that we find in our human body or air or whatever. So it is a mixture, right? Effect of temperature on states of matter. Now when the amount of sodium or phosphorus or chlorine something goes up or down in our body, we get sick. When we are sick, some organs of our body don't work well. When the organs don't work well, the proportion of this changes. If you are not able to breathe properly, the oxygen in your body will be less. If your kidney is not functioning well, the potassium or the sodium or the magnesium will not be sent out in the urine and motion, it will be retained in the body because kidney is not able to function well. So if the calcium is in short or deficiency, then your bones will not be strong. So the proportion of this in your human body has to be fixed. Likewise in the air, if there is more carbon dioxide, it will be difficult for you to breathe. If there is more oxygen, oxygen will support combustion. If there is more hydrogen, hydrogen is basically combustible gas. So those issues will be there, right? Okay, now effects of temperature on states of matter. What is temperature? Temperature is presence or absence of heat. When it becomes heat, hot, hotter, hottest, then we say temperature is increasing. When the heat goes in the negative side, it becomes no heat and then it becomes cold and colder, then it is also a different form of temperature. This increase or decrease in temperature causes changes in the states of matter. What is states of matter? Solid, liquid and gas. So changes in states of matter occur during melting, boiling, freezing or condensation. What is melting? Solid becoming liquid. What is boiling? Liquid becoming gas, water vapor. What is freezing? Liquid becoming solid, liquid water becoming ice. What is condensation? Water vapor in the air becomes water particles on the sides of a glass which is having a cold water. So gas becoming liquid. So condensation. So these are the different changes that happens on the states of matter, solid, liquid and gas because of the effect of temperature. So if something has to melt, you have to increase the temperature. If something has to boil, you have to further increase the temperature. If something has to freeze, you have to decrease the temperature. When initial decrease in temperature happens, it will be condensation. Further decrease will cause freezing. So when solid is heated, the particles gain energy. When there is heat, there is energy. Because in our body, when metabolism happens, there is energy. Heat causes energy, right? Heat energy is converted into other forms of energy. When particles are heated, the particles gain energy. So they start vibrating. When they vibrate, the atoms slightly move apart, or the atoms, components of atom, the electron, the proton, the neutron and all will start vibrating. When particles are heated, they gain energy, they start vibrating. So because of that vibration, the particles will slightly move apart, slightly, very little. You cannot measure with even with a microscope, very slightly. So this causes the volume of the matter to increase. This causes the volume of the matter to increase because they move apart. Because volume is increasing, that is the distance between the particles is increasing, the particle size is same, but overall size of the object appears to be growing. That is, the volume is increasing. That is, the distance between the particle is increasing. The particle size remains the same. So it expands. So solids expand when they are heated because the particles gain energy, particles vibrate, particles move slightly from one another, and this movement causes distance between the particle to expand. This increase in the distance between the particles will cause increase in volume of the particle, and this increase in volume of the particle will cause the object to expand. Now mass of the particle is same, size of the particle is same, number of particles is same. The mass of the particle or the number of particle does not change. Right? What changes is distance between the particles because they move apart, because they vibrate, because they get energy from the heat. This is what is happening. So the solids expand when they are heated. Now, when the particles possess enough energy, they overcome the strong forces of attraction between one another. What is the strong forces of attraction? It is the forces of attraction between different particles. It is the forces of attraction different between molecules that keeps the substance together. So when they expand, they break the bond and start moving freely randomly. The particles, when they become hot enough, they break the bond of attraction and start moving freely randomly. When particles are heated to enough extent, when they get enough energy, they overcome the forces of bonding, forces of attraction, and they start moving randomly and freely after breaking free from the bonds. This is the effect of temperature. So boiling point, liquid changes to gaseous state, melting point, solid changes to liquid state, freezing point, liquid becomes solid. All this happens because of the energy gained or lost because of the heat, right? So what have we studied in this? We have studied what is matter, all the things around us, and they are of different forms. Except heat and light, most of them are matter. They can be classified as elements, compounds and mixtures. Element is something that cannot be further split into simpler substance by chemical means. Element cannot be split by chemical means. There are 114 or 118 of them, 94 plus 24, something like that. And then we have carbon, chlorine, gold, etc. examples of substances that contains atoms of the same kind. Elements means what? Atoms of the same kind. Compound means what? Atoms of a different kind. What is that? Compounds can be split into substances of by chemical means. That means split into elements by chemical means, not physical means, chemical means. Water can be split into hydrogen and oxygen elements by chemical means. Common salt is sodium chloride, that can be split into sodium and chlorine. Different elements in a given compound is always fixed. That means what? They combine in a fixed proportion, definite proportion. Different amount of different element in a given compound is fixed. That means the elements combine in a fixed proportion to form a compound. 8 gram of oxygen, 1 gram of hydrogen together forms 9 gram of water. G is the symbol. Gram is the measurement of mass, SI unit. CGS units we have studied. Thus, elements combine themselves in definite proportion to form a compound. So, compounds is what? They have properties of their own, they have appearance of their own. Sodium chloride appearance is different from appearance of sodium, appearance of chlorine. They have properties. Ferrous sulfate is a crystal. Ferrous iron is a lustrous metal. Sulfate is not a crystalline shape. Iron is grey and metallic. Copper sulfate, copper is red and metallic. Well, crystal is blue. Copper sulfate crystal is blue. Why something is called a crystal? Crystal is called because of presence of water components in it. Hydrogen and oxygen together form a water component. The water component gives it a crystalline shape or appearance or form. When you heat it, the crystalline shape will go and it will become a powder. What is mixture? Substances that contain more than one element or compound, and constants can be separated by physical or chemical. In a compound, only chemical means. Mixture can be physical or chemical. Composition is not definite. There, it is a definite proportion. Amounts are always fixed, the amount of an element. Composition is not definite, any proportion. Filtration, sublimation, distillation are the methods for separation. Filtration will filter sand and water. Sublimation is when you heat and take only the water, is distillation. So different methods of separation by physical means of a mixture. Filtration, sublimation, distillation we have studied in earlier classes. Air contains what? Oxygen, hydrogen, etc. It also contains compounds like water vapor and carbon dioxide. So elements plus compounds together form a mixture, right? In different proportion, not definite proportion. What are molecules? Atoms and molecules are the smallest particles of element and compound. Atom and molecule are the smallest particle of the element and compound. Indivisible, smallest indestructible particle. If you destroy this further, if you divide this further, it will not remain an atom, it will become something else. That means what? Hydrogen will lose the properties of hydrogen, or sodium chloride will lose the properties of sodium chloride. That is why we call this as a smallest indivisible particle, subdivisible, non-divisible particle of the matter, element or compound, right? What is atom? Smallest indivisible part. Atomos means indivisible, that is why we call it as smallest part. They participate in chemical reaction. All atoms of an elements are alike. That means what? All hydrogen atoms are same. All oxygen atoms are same. But oxygen atom and hydrogen atom are different. Atom of one element is different from atom of another element. Atoms exhibit the characteristics of that element. What characteristics? All characteristics of that element. All hydrogen atoms are same as hydrogen element. One atom cannot be changed to another. One hydrogen atom cannot become one oxygen atom. Atom cannot be changed to another. Atoms can neither be created nor be destroyed by chemical means. You cannot create a chemical atom. You cannot chemically create or destroy an atom. Atom can neither be created or destroyed. Atom will remain same. But what will happen? Energy will be released and it will combine in different form. It will combine in different form to participate in chemical reaction and become something else. So when that happens, energy will be released or energy will be absorbed. That means what? Heat will be released or heat will be absorbed. Atoms are represented by symbols: hydrogen, calcium, magnesium, sodium, silver. We have studied this, right? Now we have something called valency. Like atomicity, we have valency. It's a combining capacity of one element with other element. For atomicity, is a combining capacity of one atom with others, and how many atoms are there together is atomicity. Valency is combining capacity of one element with other elements. Valency of hydrogen is 1, chlorine is 1, zinc is 2, nitrogen 3, carbon 4. These are the valencies. Valency is measured in terms of hydrogen's valency. Hydrogen is standard 1. Combining capacity of one element with others. Valency of other element is number of hydrogen atoms that combine. Hydrogen is considered as standard because it is 1. So when you say zinc 2, that means the number of hydrogen atoms that combine with one atom of that element, zinc. When you say carbon 4, that means 4 hydrogens combine with one carbon, CH4, it will form minimum. It cannot be something different. That is what it says. Valency of other elements is the number of hydrogen atom that combine with one atom of that element, right? Valency is also the number of hydrogen atom that one atom of that element displaces from a compound. That means what? When there is a compound and when there is a chemical reaction, a carbon has a capacity to displace how many hydrogen atoms? That is also called valency. The carbon can combine with how many hydrogen atoms? That is also valency. Valency of hydrogen is a standard 1. So Atoms do not exist independently. Atoms do not exist independently. Atoms combine together to form molecules. So H2, O2, O3 is ozone. Then we have 4, sulfur is 8, carbon is 4, like that, right? Molecule is the smallest part of an element. Molecule is the smallest part of an element or a compound. Now, why it is we say for an element and not atom for element? Sometimes hydrogen exists at H2, oxygen as O2 or O3, etc. That is why we call that O2 or a O3 as a molecule. But O alone, if it is there, then we call it as an atom. Atom is the smallest particle of an element. Molecule is the smallest particle of an element or compound because atoms do not exist independently but combine to form molecules. Molecules of helium, neon, argon are only one atom, that is monoatomic, helium, neon, argon. Hydrogen, nitrogen combine among themselves, so H2, N3, like that we have. Two or more atoms if we have, we call it as a diatomic, polyatomic, etc. and they form compound. So molecules form compound when more than one is there. What is formula? We have seen Al, if the valency is 3, then 3 hydrogen Al plus H3 can form, right? Valency of chlorine is 1, so Al and Cl will become Al1Cl3, which is AlCl3. This is a compound. The way we write AlCl3 is called the formula. When we call this as aluminum chloride, it is the name of the compound. So symbols are used to represent elements, formula is used to represent the compound. Molecule of an element or compound is represented by formula. Formula gives the number of atoms of each element in the compound. 2 hydrogen, 1 oxygen, number of elements of each element in a compound. Monoatomic, diatomic, etc. we have already studied. Formula is formed by transposing the valencies of element. That is why we study the valency. Transposing the valencies of element. Al3 will go to chlorine. Chlorine is 1. So 1 will go here. The 1 will come here. 3 will go here. And 1 we need not write. So we write as AlCl3. Valency of sodium is 1 and oxygen is 2. So 2 will come here in and 1 will go there. 2 will come to the sodium. Na2 and O. Sodium oxide. Zinc is 2. Valency of zinc is 2 and sulfur is 2. So it is Zn2S2. Zn2S2 means what? Zn, yes. If it is same side on both, we don't write it there as 2. We write it as 1 which is not written. Zns. Al1 need not be written. So valency of the elements are transposed to form the formula for the compound. Some elements have variable valency. That means what? Iron has a valency of 2 and 3 also. Then what do we write? FeCl2 is called ferrous 2 chloride. FeCl3 is called ferrous 3 chloride. So when the valency 2 is used here to combination, because valency of ferrous has come to chlorine, we write as transposed, right? Copper has 1, 2, sulfur has 2, 4, 6. So CuCl is copper chloride, CuCl2 is copper 2 chloride, Fe2O3 we are using the third valency, it is iron 3 oxide, that is how we call it, right? This is not sulfur and oxygen, this is SO2. So we have studied about matter around us in this session. Thanks for watching this video. Please keep coming back.